Okay guys, so we're here with our last section, section 10.7, and the key to this section, all right, before we actually kind of dig in to the different theorems, is we're now looking at the individual segments within these chords and within these secants, okay? So we're switching our mindset from angles into secants. So what we're going to do is we're actually going to jump right in to 3 theorems, and then we're going to apply it throughout, okay? So the first theorem is 10.15, and we're not actually going to write a formal definition for it. What we're going to do is we're going to write just a quick intro and then draw a picture and then write a formula, okay? So if we start off here, it's going to start off with if 2 chords intersect in a circle. Okay, so if 2 chords intersect in a circle. So what I want us to do is we're actually going to draw the picture in this box, and then we're going to write a formula for it, okay? So let's go ahead and start with our circle. And we're going to draw 2 chords that intersect on the inside of that circle. All right, so I'm going to draw this chord right here. Okay, draw another chord right here. And what we're going to look at these individual segments within these chords, okay? So I want you to go ahead, and we're going to start with this chord right here. Let's go ahead and put all these little intersection points in so that we can label them point, 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 and point, okay? All right, so up at the top, we're going to go ahead and call this point D. Let's go over, call this A. Let's go down, call this B, over to E, and then C is in the middle. So what I want you to look at is I want you to look at the individual segments within those chords. All right, so for example, I want you to look at chord DB and how it's split into DC and how it's split into CB. And then similarly, I want you to look at the other chord and it's split into AC and it's split into CE. So when we're looking at these segments, all right, we're talking about the lengths of these segments. And so what this one says is if I wanted to find these segments, okay, then we're going to split them individually, and I'm going to take the length of DC and multiply that times the length of CB, and that's going to be equal to the product of AC times CE, okay? So what we did was we took one of those chords, split it into its individual segments, multiplied them 2 together, and we're going to do that with the other chord as well. All right, so we take AC and we multiply it times CE, okay? So what we're going to do is in example 1, all right, is we're going to practice that, all right? So what I'm going to do is I'm going to look at this chord of ED, and I'm going to notice it's split up into X, and then it's split up into 10. All right, so I'm going to take those 2 segments and multiply them together. So I'm going to do 10 times X equals, and I'm going to do the same thing with the other chord and how it's split into 5 and it's split into 12. All right, so I'm going to do 10 times X is equal to 5 times 12. So multiplying that out, I'm going to get 10X is equal to 60, which means X is equal to 6. And that's your final answer. All right, not that hard. Let's try the next one. All right, so same idea. I like to start the one with the X. So I'm going to do 6 times X. So start there. So 6 times X equals, and then I'm going to look at the other chord, and I'm going to do 4 times 15. Okay. All right, so simplifying that, I'm going to do 6X is equal to 60, which means X is equal to 10. And that's your final answer, okay? So when the intersection of these points are on the inside of the circle, what we do is we take the individual segments of each chord, multiply them together, and then set them equal to the other chord, all right? So not that bad. But the other ones aren't that easy, all right? So what we're going to now look at, all right, is we're going to have 2 secants. And this time, all right, their intersection point, so 2 secants intersect from an exterior point. Okay, so again, we're going to draw the picture, and then we're going to go ahead and write the formula. All right, so let's go ahead and start with our circle. And this time, we're going to have an intersection point on the outside, and we're going to have two secants that are coming from that point. So we have this one, and then we have this one coming out here. Okay, and then let's go ahead and mark each of those intersection points, and then we're going to have to label them. So let's go straight across here. We're going to have A, we're going to have B, we're going to have C. All right, and then we're going to go down to D and then over to E. So here's the key here. All right, common mistake I'm going to tell you guys ahead of time. All right, so what the process here is, we're going to take this exterior segment. All right, so if you look at this segment of BC, all right, so we're going to take that segment of BC. And then the key here is we have to multiply it times the entire segment of AC. All right, so then we have to multiply that times the entire segment of AC. Equals, and it's the same pattern. All right, so I'm going to take that exterior segment of CD and then multiply that times the entire segment of EC. All right, so then we have CD times EC. Okay, so to write yourself a note, we're going to do the exterior segment times the entire segment. Okay? All right, so I'm going to pause here, and then we're going to come down and practice these. All right, and then we will do our last type and then do some